Okay, we get started. This presentation session is about pumping lemma and context-free grammar. And Matt is very kind to write his solution for the second problem in our first quiz, which is to prove that WW, which is in 01 star, is not regular. And today we show that it's not even context-free. So we start from Matt's solution. Everybody understand what Matt is doing? Yes? Be sure, because we're going to build upon that. To use pumping lemma to prove that a string is not regular, first thing we do is we assume some pumping length p. That is fixed. And it's p, we don't know exact number. And you cannot assume that p equals 2, p equals 3. That would not work because p is some number we don't know, but there is a p. So given a length p, then as Matt said, the only thing that we actually can do is to choose a string whose length is greater than or equal to p. And in the pumping lemma of regular language, you always want the first string to be of length p or greater than p. Because the pumping lemma for regular language says the x, y, z, the x always start from the first one, always start from the beginning, and x, y is less than p. So if your first substring is greater than p, then you basically restrict that the value of y is in the first substring. Everyone follows, right? Okay. Then it comes the pumping part. For the pumping part, you cannot take some specific value of x, y. In the quiz, somebody take, for example, x equals empty and y equals 1, 0, and show that that case cannot be pumped. It's correct, but it's incomplete. Because once you have the string, you have to reason about all possibility of x, y, z, not some specific value. So you have to talk about when x is epsilon, y is 1, 0, 2, 0, 3, 0, until p number of zeros. And the case where x is 1, 0, y is the rest of the zeros, so y can be either 1, 0, 2, 0. Yeah, there are a lot of cases. And I don't think you can write in the test for each one of them. So the strategy is to find some patterns. So in this case, the patterns Matt found is no matter what x it is, it doesn't matter, but y must contain certain amount of zeros. Because for the pumping lemma, one of the restrictions is xy, the length of xy is less than or equal to p, and the length of y is greater than 0. So in combining these two conditions, y has to take certain amount of zeros, and y cannot take any substrings beyond the first set of zeros, because the length of xy must be smaller than or equal to p. And once you find this pattern, this covers all the cases. Then you can reason about the pumping. So if you pump down, since y contains certain amount of 0, then the number of first 0 must be less than the number of second zeros. Then we are basically done. You've already showed that once you pump it, it's no longer in the original language you start with. Any questions up to this part? No questions? Okay. Then I assume that you all understand the pumping lemma for regular language.
For this example, yes.
Okay. Yeah, the pumping lemma for context-free language is a little bit more difficult. Do you still remember what it is? Yes, no? Yes? So the pumping lemma for context-free language says instead of x, y, z, I think it has x, y, z, u, v, x, y, z. You can split the string into 5 substrings, and the restriction is only vxy is less than or equal to p, right? And u, v, I, x, y, I, z is not in the original language. So if we compare these two versions of pumping lemma, the pumping lemma for regular language always pump the beginning of the string, while pumping lemma for the context-free language pumps essentially any part of the string.
So you can be empty as well? Can you repeat that, please?
You can be empty as well, yes. Yes, pumping lemma for the regular language only pumps the beginning of the string.
Beginning?
Right, because xy, the length of xy is less than or equal to p. And x is always the beginning of the string. That's why you kind of try to make the first substring of length p. That will restrict y. In the pumping lemma for context-free, you cannot do such thing because you can be anything. You can be of length p plus 1. So you cannot restrict the pumping to be only the first substring anymore.
So
yes.
You really have to consider any division of that? Because
yeah, you still have to. Which one? Which version?
On S for regular or for non-regular languages.
Yes, you
focus on the first part of S, right?
Yes. Yeah, you focus on the first part of S, and then you have to consider all the cases. So, and here, pumping lemma for context-free, you have to pump both v and y the same number of times. It is the same I. So whenever you pump v once, you have to pump y once. That's what it says. Okay.
Can we make just y empty, but we have something in v?
Y can be empty, can it?
Because the requirement was that the length of vy is greater than 0.
Oh, okay. Yes, then y can be.
Only one of them really needs to have.
Yeah,
So the other one
y can be empty.
Okay.
Yes. Okay, everybody follow this part. And because of this difference, the string we typically pump in context-free language is no longer of this form, where the first sub-language always p. But we make every sub-language to be the length of p. Why is that?
So it restricts all this almost?
Yeah, we try to eliminate the possibility we need to consider. So let's go back. If p is 1, the only restriction we have is vxy is less than p. Then what's the possible value of v and y? It can be here. We can contain 0, 1, and X can be empty, and Y can contain the zeros, or V contains zeros, X contains 1, Y contains zeros, or all the possible ways, I would say. But if the length of P1 is P, then X, Y, Z cannot range over 3 substrings, 3 parts. It can be only entirely here, or somewhere here, or entirely here. It cannot go beyond that. Do you guys follow?
Yeah.
Okay. Yeah, so you always want to have your string of this form, because that will greatly eliminate the possibilities you need to consider. Yes? Then can you guys continue from here to prove that this is not context-free? Or you want me to show example and you do the second problem? Well, okay. Yeah, I'll do the first problem then. Everyone understand math solutions, right? Then I will start from here. Okay. We consider certain cases. As we discussed here, V and Y can, okay, so V itself can take 2 symbols. Like V can be anywhere between 0 and 1, right? Okay, if V or Y contains 2 symbols, in this case, if we pump up, what will happen?
Both of those characters will go longer, so we'll get more zeros and more ones.
Actually, it's worse than that. Let's look at one example. We have 0p, 1p, 0p, 1p, right? Take one example. V is somewhere in here, 0, 1. X is whatever. Y is some 1s, and Y has to be 1s. What happens for UV2 X, Y2, Z? What's the result of pump it once? We will have 0p minus 1, 0, 1, 0, 1, and then the number of ones. Probably, yeah, there could be more. There could be more ones. Right? Yeah, we can ignore the other things, but basically, we create two copies of 0, 1, 0, 1, which screw up the order. So if V contains 0, 1, then if we pump it up, it will be of this form. It's no longer in the form of 0p, 1p, 0p, 1p. Because we have an extra 0, 1 in between the ones. Any question?
So because that would be the same result if you did it with y, would we still want to show that case, or would it be implicit? Here, y contains both symbols.
Well, once you fix V to be 0, 1s, then y has to be taking 1s because uxy is less than p.
I mean, like, there's also the case where y could be 0, 1.
Oh, yeah, when y cannot be 0, 1s because V is here, then x and y must be only in 1s. Do you understand why?
Yeah.
Okay. Yeah, so if V or Y contains more than one symbol, if we pump up, then we screw up the order. Understand? Okay. That's all you need to write here. If they contain more than two symbols, then pumping will screw up the order. Full point. Case 2. V and Y contains only one symbol. How many possibilities are here? Okay, it can be all zeros, it can be all ones, all zeros here, all ones here, or one of them can be 0, 1, the other is 1, right? Yeah, so I will say there are two cases. 2.1 is V and Y are the same symbol. And for this case, the same symbol cannot be, it cannot be the case that V is in the first set of 0 and Y is in the second set of 0. Right? So if they are the same symbol, it must be in the same set of zeros. Questions? Do you guys follow up to here? Why? Jeff, tell me why.
Well, he just said the length is less than p.
Yeah, exactly. Okay, so if they only add one set of zeros, if we pump it up, what will happen? We'll cause the first set of zeros to be greater than the second set, which screw up the language again, right? So this case is proven. Basically, if they are the same set of symbol, then we pump up, the two sets of symbols must be different. Second case, V contains, sorry, contains zeros or ones. And Y contains 1, ones of zeros. What happens in this case? So v and y are somewhere in between the two sets, zeros and ones. If they are here, we pump up. The first 0 ones will have different number than the second 0 ones. Yes? And same in here. If we pump, so for example, if v is in ones, y is in zeros, we pump up, we'll cause the first set of ones to be greater than the second set of ones, but the first set of zeros is less than the second set of zeros. Yes, Jeff?
So for this division, x is some of the ones then?
Yeah, we don't care about x, since we're not going to pump x.
Because it has to be less than or equal to p for vxy, right?
Yeah, we can make sure that. So we written about in this case, it cannot be pumped too. Questions? Yes?
Am I understanding it correctly that the case doesn't work because W V could contain zeros and ones? Not the guess.
If V contains zeros and ones, it's case 1, basically.
Yeah, but for case 2, like, what if W is just a bunch of ones?
Oh, we've already chose a W.
Oh, okay.
Not WS. Yeah, but essentially Ws. So you don't need to reason about arbitrary strings here. You only select one string and stick with it to reason about it. Yeah, that will be the proof.
So therefore, it's not context-free.
So yeah, therefore it's not context-free. You will want to understand this process because most of the proofs are exactly the same reason. Questions? Yes?
For 2.1 and 2.2, does pumping up and down, like for both of them, they make zero work? Just one or the other?
You just need to show one.
Okay, but I'm saying for this one, what's the first one and what's the second one?
It doesn't matter. Either one will work.
Okay.
If you pump down, then you just simply decrease the number.
Yeah,
Pump up, yeah. You guys follow the reasonings here? Because I can tell you for the second problem which you are going to do, it's the same reasoning. Just pick the right string. Yeah, if you claim that you follows, then you do the second problem. If not, you still have chance to ask questions.
So for 2.2,
Yes.
it contains zeros and ones. Are we focusing on V when it contains one symbol?
Yeah. Let me
Zeros or ones.
write it this way. I'll make it clear. Okay, second problem.
Just did the same condition.
Which one?
Initially there was lower one and also.
Right, I try to make it less confusing. That's it.
What are we saying? This split into two conditions. If you write the other way, that's also correct.
Which way?
When you combine both conditions.
Yeah, if you combine, the reasoning is essentially the same. So. Yes? Oh, the pump. Pump is just one character, one symbol.
A separator.
A separator. An example of that string will be a pump B by pump A, something like that. So yeah, it's just to separate the strings.
So the strings are all arbitrary strings of AB star.
Right. For anything between the separator, yeah, they're arbitrary string of AB star.
What is the second condition?
Second condition means there must be two strings which are separate. Sorry, yeah, there must be two strings which are exactly the same.
Any two.
Yeah, any two.
It doesn't have to be the ones.
So in this case, we can find the first and third to be the same, which is an example of the language. And this one, AI, B, J, would not be a string because there's nothing to be the same. Okay.
Sorry, I wasn't listening.
Sorry?
Can you repeat the pound sign?
Oh, sure. So this, whatever string that belongs to a language is in this form, where the pump side separates arbitrary strings in AB star. And there could be as many pump sides as possible. And for the string that are separated, at least two of them should be exactly the same. It's difficult to understand, but you don't need to read about all strings in the language, right? You just need to pick one string which can be pumped. And I've already told you that it's of this form. But you always want to make string of this form because it's easier.
Well, we have pounds in between, right?
Yeah, you can put pumps in between. It doesn't hurt.
One of these conditions can be pumped using this.
Sorry, for this one? You have to talk about all cases.
Only one condition can be pumped. What can we conclude?
Oh, it does not means that it does not prove that it's context free. It's only so pumping lemma only says that if a language is context free or regular, then it can be pumped. It doesn't say that anything can be pumped is regular. Yes, Moody.
Can we just do 0p, 1p, and then take case 1 out?
Now you cannot do 0p, 1p. You can do 0p pump 1p.
Pounds, we have to do the random string in the middle.
But 0p pump 1p is not in the language.
Oh, it's actual pounds.
Yeah, there are extra pumps involved.
Okay.
Yes.
If it is regular, then every string will be pumped. Every string, any combination can be pumped, right?
Right.
So to prove that it is not regular,
You have to show-
just one. Why?
Right.
Why are we showing all these cases?
To prove it's not regular, you show that one string cannot be pumped. And for the one string cannot be pumped, you have to show that for any cases, it cannot be pumped. Yes, Jeff.
Does doesn't equal J restriction do, like, I know you explained it, but I'm still
Yes. So there's certain string that's separated by the pump side, right? And that condition says at least 2 of the strings must be exactly the same.
Is there a way to tell how many cases a problem might have, or is it kind of like an intuition thing? Because like this one had 2 cases, and the I less than J less than K had 3 cases.
Which one?
This one that we did on the board has 2 cases.
It depends on the string you picked.
Yeah, is there a way we can tell by looking? Oh, it depends on the string.
Yeah, it depends on the string.
Is this a valid string language? Am I allowed to do AV like that? Or does it have, that also has to be separated by pound?
Well, you can say this is one string, then you don't need to separate them by pound.
Okay. All right, thanks.
Any more questions? Can anyone tell me what's the string you want to start with?
This is a good string. A, P, to P,
pound,
to P, pound,
EP.
A to P.
Sounds like a good string to me.
Look good.
Then how you pound it? Oh, sorry, P.
Just like a comma. It's kind of tripping me up in a way. I figured about using, like, coming to the case for 2 symbols. Yeah. Yeah, it's got to stand across the 8. I don't know if you can.
That's a really good question. If you, like, say your V, can you select V to contain a pound?
Sure.
But then that's trivial though, because if you pump V with a pound in it, you break the language.
Yeah.
Because you either remove or add a pound, and that can't be.
So
You can pump it down. You can pump it down, right?
yeah.
That's one case down.
Upwards.
Yes, Modi.
Would it be easier if we made it P-1 so that we can include the pound in each?
Oh, but see, it's just a condition, so it does not force pump to be included.
We could pump up or down, is that correct?
Yeah, you can pump up or down.
Okay.
the case like VXY is all P's, pump it, it would still be in there, wouldn't it? It'd still be in the language, wouldn't it?
VXYs are all B's.
Yeah, if you make it all B's,
If it, yeah,
entirely all B's, and you pump it up or down, it's still in there, right?
right,
So then the string doesn't work, right?
correct,
Case.
correct. Okay, actually, Jeff raised a very good question. For this string, if V, X, Y are all in B's,
Then it can be pumped.
it can be pumped. You have to find a different string.
Would this string work? You do like A, this one that I crossed off, A, P, with the extra P here.
Oh, but if we pump this one, it's still there, right?
Yeah, you're right.
So how about AP, BP, pound, AP, BP?
Okay. Yes.
If as he said, X, V, X, Y, everything is in B, it can be pumped or up or down and still it belongs to the language, right?
Right.
So what is the conclusion?
Conclusion is the string you chose is wrong. Pick a different string. This is what Nico suggested. Any comment? Can either be here.
There's not two pound signs, and you need another pound, right?
Oh, you only need one pound sign.
Usually two strings.
Yeah, for two strings, you only need one pound sign. Can it be pumped or not? No. Okay. Yeah, then Nico did the most challenging work for you guys. Then you have to show the cases.
Sorry.
Nico, do you have a solution?
Almost, not done yet.
Okay, we'll wait. Anyone has a solution yet? Yes.
Is the reason we got rid of the first string because it wasn't in the language, or because it didn't work?
It didn't work. You do you know why it didn't work?
Or you could program pump the middle string that has A, B, O, B, B, and then up to the middle string. We'll skip this one. We had to have T, so if you
Okay, anyone has a solution?
Yeah, so,
Sure.
Okay. This one, consider all these the same, so yeah, this here for 1, 2, and 3. Case 1. You have V or Y contain a symbol. Oh, let's say the alpha symbol / pound. And so, if you have V or Y, let's say for example you have V right here, and then you have Y containing the pound. If you pump this, you get an extra pound in the middle, and that's no longer inside the language, so that breaks it. You could also do the situation in which you have, I guess,
Why does it break?
why does it break?
Yeah.
Because you're only allowed to have 1 pound in between 2 parts of the concatenation, the A, B star.
Can you show me what's the result of pumping?
The result of pumping, you would get A, P, B, P plus 1, and then you would get that, and this being V2, and this being Y2, A, P, B, P.
Okay.
So,
Why does it not belong to the language?
because it has to be in the form of T1 pound T2.
Okay.
It's no longer inside that form.
But I can also consider here is an empty string, right?
Okay.
That's right, because now the two strings are equal.
Yeah, that's the reason.
Okay.
So you have to have at least 2 strings that are exactly the same.
Okay.
If you pump in this way, then this and this are not equal.
Okay. So we have that case.
Okay.
This that breaks. We also have the case where, yeah. So I talked about the case V under this and then Y under this. But you can also have the case, I guess, V taking over those 2 and then Y being right here. And
Okay.
this breaks also because you would get A, P, B, P plus, you get, yeah, BP plus 1 BP. So it breaks again because at B.
They're not two strings that are equal.
Yeah. Yeah. Yeah, B plus 1 right here and ABP. So that breaks that.
Okay.
And then you also have the case where V and Y are in the symbols, or in just one symbol.
Okay.
So case 2. So in this case, you can have V be right here, Y be right there, for example. And if you pump these, then you get AP plus 1, BP plus 1.
Okay.
And that breaks it because, again, T and I aren't equal anymore. And those are the two strings need to be equal.
Oh, they can be the same symbol. They can be same in
yeah, or you can have VY, and then you get AP plus 1, but again, it breaks TI is not equal to TJ anymore.
Okay. Have you covered all cases?
I believe so.
Let me show one case where V is empty string, X is empty string, Y is the pump side. What happened in that case?
And you have 2 pounds in a row.
You have 2 pumps in a row, but is it illegal?
Oh, no, it's not.
No, it's not.
Illegal.
How to deal with that case?
Pump down
Pound to
direction.
P.
No, pump it down.